So let's consider a single spring mass system. This is on inclined plane, so we need to find out the natural frequency. The surface is smooth, so first we consider the static. As usual, we consider the static part. If the spring is at rest, so when the spring, when the under static loads, that is only the weight, what is the deflection of the spring? So let's say this is the equilibrium point. So under static deflection it would have deflected by some amount. Okay, let's say that deflection is delta. Okay, and so this is the force acting at the static, which is Fs, and this is your normal reaction. So mg generally acts vertically downwards, but now when you resolve it, and the component along the inclined will be your, so this is theta, so the vertical mg mates with the inclined theta, so this is also theta. So mg sine theta is the force that is acting along the incline, and that is the force that is resisted by Fs, because there is no friction along this direction. So mg sine theta is equal to Fs. Okay, that is Fs is nothing but your k delta. Okay, so this is at the time of static deflection. Now if I, so this is static deflection, okay, it has gone delta. Now if I perturb the mass by x and leave it, when I perturb the mass by x, the mass occupies this, the total stretch of the spring is delta plus x. Okay, so at this point of time the forces on the mass will be mg sine, the weight will remain same, weight will not change because of by perturbing by x. So mg sine theta acts downwards, and the force from the spring is upwards, acting upwards along the incline, so it is k into, now the net deflection is from the free length, this is the free length, from the free length is delta plus x perturbation. This provides the unbalanced force, and that is mx double dot. Okay, so now this equation is mg sine theta minus k delta minus kx is equal to mx double dot. Now from equilibrium we know that mg sine theta is k delta. Okay, so these two terms will just cancel each other, and what we will left is mh double dot plus kx is 0. So this is again as the governing equation for a spring mass system when it is just on the floor. Okay, so inclined sense doesn't matter when it is just hanging or when it is just on the floor. Okay, so this is just similar to that, and if so, acceleration can be written as minus k by m into displacement, and what is written as in the bracket, that is your natural frequency. So omega n square is k by m. So this we are just writing acceleration is equal to some time, acceleration in a simple harmonic motion is equal to your displacement, and the scaling constant is your omega n whole square, so root k by m. So this is, I mean, from the equation itself you can say, if the equation is in this form, the natural frequency is root k by m. So the incline really doesn't matter. Okay, root k by m. So we have just derived from basics. We have considered the static, and then we have considered by perturbation, and consider the dynamic equation. So incline doesn't matter, root k by m. Thank you.